Okay, before we get started, I have an announcement, another one about the peer mentoring program, which is really important.
Hey guys, how's it going? My name is Dax. I'm currently a senior with the computer science program. I'm here to talk about CS mentoring. Some of you may have signed up, you may have met your mentor. A lot of you probably have not or may have not heard of it. It's a great program. You get lined up with juniors and seniors in the program. They can help you out with internship information. They help you out with picking out classes, kind of helping you learn about the program. It's something that didn't exist when I was a freshman. And having a little bit of mentoring, a little bit of advice from someone who's gone through it would have been really helpful for me, which is why I volunteered in the first place. We have an event this Friday from 12 to 1 p.m. in the Catmull Galleries. That's in WEB, in the main lobby there. And a lot of the mentors will be there. You can meet us. If you should have gotten an email from your mentor if you did sign up. If you haven't for any reason, feel free to reach out to Tracy and them as well. And we'd love to see anybody at the event this Friday from 12 to 1 p.m. again. If you have any questions, you can ask Joe. He's got my email and he can get in contact with me. Does anybody have any questions about that? I think you got an announcement last week as well. Cool. Thank you guys.
Okay, so PS7 is out, been out I guess for a week, but anyway, it's due Thursday, and on we go. The lab tomorrow will be devoted to looking at your graded exams and going over the solutions, so you don't want to miss that. Any questions or problems about anything? Can I help you with? Okay. I got a question for you. What do you think was the hardest question on the exam? You put it out of your mind, but yes.
Can you give us a list of what you think the hardest questions were? Because I completely forgot the exam.
Okay. Well, I'm about to talk about the hardest question on the exam, and in fact, that's a hint to what the hardest question was. Anyone? What's that?
That one was so hard. I looked them, but yeah.
The question about?
Yeah.
No.
Yeah.
Okay, yeah. And I know it's the hardest because I just looked at the percentage score on every question, and that was the lowest. So if that's in a program, something.f is a static method call, then what has to be there in place of thing? Okay?
It's a class.
Right, it has to be a class name, right? So here's some examples. Math.square-root. You know, if you're calling a static method, you have to say what class you're supposed to get the method from. So math.square-root, integer.parseInt, method library.isPalindrome. In all those cases, you give a class name dot static method. That's how you call static method. So that's the answer to that. It's a class. Okay? On the other hand, what if it's non-static method, such as s.hasNextDouble, list.add hello, ran.nextIn 100. Those are non-static methods, so object. Right. Non-static methods, when you call them on an object. They operate on an object. They tell you something about an object. They change something about the object, whatever. Okay? So that's the key difference between static and non-static methods. Okay, now let's continue thinking about this. I'm going to give you a method here. That's a static method, math.square-root of 3.5. When square root starts running, what parameters is it receiving? Yeah, 3.5. Right, there's one parameter, 3.5, and that's what the method operates on. If you looked at its header, it would have one parameter listed in the header, a double. What about parseInt? Right, the string 52 is the parameter that gets passed in. This isn't hard. There, the parameter is the string rotor. Okay, so for static methods, you just look at what's in the parentheses after the method name, and those are the parameters that are being passed. Okay. Here's, in this case, now we're looking at non-static methods. S dot has next double. What parameters are passed to the method in this case? Okay, what do you think? Are there any parameters? Yeah?
This.
Okay, he said this. So basically, that's you got the right idea. It's whatever string S references. I guess that's scanner. Sorry about that. Whatever scanner S references. That's called the implicit parameter to the method has next double. Inside has next double, how can you refer to that implicit parameter? Because it doesn't show up in the parameter list. Want to say your answer again?
This.
Yeah. You refer to it as this. So inside the method has next double, if you're going to refer to the object on which the method was invoked, S in this case, you use this. This refers to it. And that's just a Java keyword. Okay? What parameters are passed to add? To add. How many parameters are passed to add? 2. One of them's easy to see. It's hello. The other is whatever object list refers to. 2 parameters. So when you're calling a non-static method, you're always invoking the method on an object. And that's important because the method wants to do something with an object. You have to tell it which one to do it to. Okay? Similarly, we call rand.nextInt. There are 2 parameters. There's whatever object rand refers to, and 100. Inside these methods, you can refer to the object in which the method was invoked as this, if you wish. Okay? Now, here we have a class C that contains a method F that's calling G and H. Okay? So for whatever reason, that's what the implementation looks like. It calls G and then it calls H. The first one's a static method. So we said that when there's a static method, you need to say what class it's from, but it's missing here. So in this case, it's not explicitly there, so but it is implicit. There's a default value. Why can we leave the class name off here? Yeah?
Because it's in class C.
Because, yeah, we could leave it off, assuming that G is a part of class C. Okay? So if you leave the class off of a static method call, then it defaults to the class in which you're making the call. Okay? And we're familiar with that. Now, what about that second case there? We're calling H, and there's no object in front of it. There's no object dot H. It's just H. So what does that mean? Is there some default object that H operates on? If so, what is it? Yeah. Okay, she said it's operating on the object on which F was invoked, which would be the right answer except for one detail. Was F here invoked on an object? It's a static method. So there is no object in which F was invoked. So what do you think of that call to H? Yeah?
It's calling a different method in C.
Well, suppose that he said it's calling a different method in C. But if it's a non-static method, you have to invoke it on an object, right? There's an implicit parameter that has to be passed into H, and it's the object on which H is invoked. So even if that method is in C, I've got to know what's the object H is running on. If H modifies an object, what object will it modify? What do you think?
This.
Well, he said this, but inside a static method, there is no this. This can only exist in a non-static method because this refers to the object in which the method was invoked. And this method was not invoked on an object. F is static. Yeah?
I think it has to be a C object.
Well, he said it has to be a C object, but what
C
object?
has a constructor, then it would be an object of type C.
Okay, maybe it's of type C, but where is it? What object are we talking about? Yeah,
Whatever precedes the dot.
it said whatever precedes the dot in the method called to F.
To
Well, but there, okay, so for H, there is no dot in front of it. Okay?
yeah.
Okay. You can't do this. Now, a lot of you will try. You'll be in a static method and you'll try to call a non-static method, and you'll get some kind of error from the compiler. And one of the suggestions it will make is, you know, this would work if H were static. So you'll go, oh, that's great, let's make H static. Then you make H static and suddenly you got more errors because H wasn't written to be static because it needs to refer to instance variables. And so you may be tempted to make those variables static. I've seen students that get that single error because they made a mistake calling a static method, and they end up declaring everything in their whole program static to try to get the errors to go away. So don't do that. The suggestion you get isn't always the right thing to do. Okay, so you just can't do that sort of thing. If you're going to call a non-static method from inside of a static method, you've got to supply an object for it to operate on. Okay? So C is the default for the call to the static method, but you can't call the non-static method that way. Now what about this situation? Now I've made F non-static. I took the static keyword away. So, okay, there's a missing class name in front of the G. What's the default? Yeah. C, just like before. Great. There's a missing object in front of H. What's the default value? On which object is H going to be invoked if you do this? Yeah.
F.
Well, F's not an object. That's not it. I had 3 people that answered it correctly before, yeah.
The object that called F.
The object on which F was invoked, which is called what? This. So this version here is shorthand for that. So if you call a non-static method from inside of a non-static method, then you're invoking it on this. You're invoking it on the same object that F was invoked on. And you tend to take advantage of this a lot. Okay? Key thing to remember, static methods don't operate on an object. There's no implicit parameter to a static method. Non-static methods, there's that implicit parameter. It's always operating on some object. Okay, before I go and look at something else, is there anything, any way I could clear up? Because the problem with it is, you know, we talked about this like a long time ago, before fall break. So we were trying to remember what we talked about before fall break. I know that's hard, but it's crucial to this week's assignment. You'd be implementing a couple of classes. Okay, now, you may remember that right before fall break, we implemented a class called MyList. And just to remind you, let's go look at it. So here's the class, it's called MyList. The idea was it was supposed to be sort of like an array list, but it was supposed to only hold ints, just to keep things simple. Yes?
What day was this from?
This was from the Thursday before fall break. Don't know what.
I'm looking for the correct file.
Yeah, I don't, you have to look at your calendar or something. I don't remember the exact date. Okay? Now, let's see what we did. We had a constructor that created an empty list. We have a method get that takes an index and tells you what is stored at that index. We had a method set that takes an index and a new integer and stores the new integer at the index. We had a method to add at the end of the list, and we had a method to return the size of the list. Now notice it says return the length of this list. Append an element to the end of this list. holds the element of the list. What list are we talking about here? The get method. What list does it get the element from? Set method. What list does it set? What list are we turning the size of? This list. In other words, size has to, if size is called, it's being invoked on some list object, some MyList object. It's operating on whatever one it was called on. So there could be thousands of MyList objects out there. You can create them with a constructor. Remember, this is the constructor that creates them. So you can create all the MyList objects you want, like in this main method here. I create 2. And then when you want to add something in the list, you have to say, which object are you adding to the end of? List 1 or list 2? Okay? So when we implemented this thing, we had a key decision to make. And it is the key decision, it's the most important decision you make to implement a class. And that is, how are we going to represent the values of lists? How are we going to keep track of the elements of a list? And what we did was, we decided we'd use an array. So we declared that variable. That's called an instance variable because it's not static. It's an instance variable. Now what does the word instance variable suggest? Yeah. Okay, every instance of the MyList class, every object that you create will contain within it a variable data. So you're used to looking at a variable and saying, there's one variable called data. But in fact, if you create 1,000 objects of type MyList, each one will have a variable called data. So let's say we go to get an element out of the list. We say, give me element 5. And we go and look in the data array and return element 5 from it. Which data array? There could be thousands of data arrays out there. The way the code is written, it looks like there's only a single variable called data. But in fact, there are a bunch. So which data, where are we getting this data variable from? Which of the thousands of arrays? How do we know which one to access? Yeah. Yeah. We look at the data field of the object on which get was invoked. So if we did list1.get of 0, we look inside of list1 at its data field. If we do list1.set, we look inside list1. So this is actually shorthand for this.data. This is shorthand for this.data. We're looking at the data field inside the object on which the method was invoked, which is this is definition. So if we wanted to, you can see why we typically leave out this. But we could qualify every single reference to data with this. And then it makes it clear there is this, see, it looks like size takes no parameters, but actually it does take a parameter. And that's just the object on which the method happened to have been invoked. So we take that object, we go inside it, we get the data array out, we calculate its length, we return it. So moral of the story is, when you're looking at a class, when you look at the instance variables that are declared in the class, you've got to say to yourself, don't be tempted to say, the class contains a variable called data. No, don't say that. What should you say? What's the right way to put it? Instead of, the class contains a variable called data, what? Yeah?
The object.
Well, yeah, every object of type MyList contains a variable called data. Right? Every time you create a new object, you're getting a chunk of memory with the data array inside. All right, so let's go back to here. So this is the instance variable inside of the first version of MyList. So it's an array of integers. And we have to give a comment here. This comment is extremely important. It's not for the consumption of the users of the class. It's for the it's for you. It's for the implementer, so they remember their decisions. We have to say how this array relates to the list it's attempting to represent. So we say it holds the elements of the list and is exactly the same length as the list. And element I of the list is stored at location I of the array. So it's a very straightforward representation. Okay? And you remember the trick was our abstraction, our MyList objects can grow as you add things to them. And an array can't, and so each time we wanted to add to the list, we had to create a new array that was longer. So if you understand your representation strategy, this is the representation strategy. So when I say in an assignment, one step is to design a representation strategy, what I'm saying is you got to figure out what instance variables you need, and you need to comment them to say what they're for. Okay? So let's see if you understand. There is, suppose we cut a MyList object open and looked at the debugger, and we found that it contained an array that contains the numbers 1, 5, 9, and 2. Okay? What MyList object is that? What MyList object does that represent? Does it represent an empty MyList object? Does it represent a MyList object that contains 7? What MyList object does it represent? Yeah.
This one?
This isn't the answer to everything, unfortunately.
Sorry, I got nothing.
If we print it out, so we've got some object, it's a MyList object, it contains the array 1, 5, 9, 2. What can you say about the array list itself when you think about it abstractly? You don't want to when you look at it, you don't want to think of an array, you want to think of a list. How many elements are in the MyList object that contains this array? 4. And what's the first element? 1. So it's such a direct representation that it's easy to confuse what's the concrete thing. The actual thing you have is an array containing 1, 5, 9, and 2. And what that stands for is a list that contains 1, 5, 9, and 2. It's just a one-to-one correspondence. In this case, it's pretty easy. So suppose you have a MyList object whose data variable is an empty array. Okay, what kind of MyList object do you have? An empty one. So we got the concrete view, what you really have, and the abstract view, what you want, the way you want to think about it. When we're using MyList objects, we don't want to think about arrays. We want to think about lists. Okay, what about that one? You have a MyList object that contains 9 and 2. Where the data array contains 9 and 2. Which one is it? What MyList object is it? Right. Pretty simple. Okay? You should be able to go the other way as well. How would you represent? Suppose you know that you have a MyList object that contains 4, 3, and 8. What would you expect to find when you cut the object open? What would be inside it? Yeah?
An array of 4, 3, 8.
Right. It would be a data array containing 4, 3, and 8. So it's equally easy. If you have a MyList object that's the empty list, it will contain an array that's an empty array, and so forth. Okay? So that's all very straightforward. Now, let's look at a different representation. What we did was we first implemented that one version, and we actually timed it. We did, I don't know, 400,000 adds to it, and it was pretty slow. It may have taken 15 seconds or something to do all those adds. Then we came up with a different strategy. So this is the representation for the second version. So first of all, we have an instance variable that contains the number of elements in this list. So we got a variable. You crack open this new kind of MyList object. Inside you'll find 2 variables. One will contain the length of the list. The other will contain an array called data. But things are a little bit tricky. Read this comment here. The elements in this list are stored in data 0 through data subcount -1. And the length of data must be greater or equal to count, obviously. You wouldn't have room for all that stuff, but it can be longer. Okay? And we did it. Why did we choose this representation strategy? Think back 2 weeks. It let us do a much faster implementation, but yeah.
Yeah, adding or taking objects away is much faster.
Okay. So the bottom line is, in the old representation, every time you wanted to add an element to the list, we'd have to take the data array, copy it over into one that was bigger, one element bigger, and store the new element at the end of it. So we had this copy every time we did an add, and that was expensive. When we went to the second version, we made it so that we started with an array of length 2. It would fill, let's say, and then if someone tried to add to it and it was already full, what would it do? What would our code do if someone tried to add to a my list when its data array was already full?
Double the length of the array?
What we did was we copied over into a new array that's twice as long. And that left us room to grow at the end. So at any given time, it may be that abstractly, if you think about the list, it may only contain 5 elements, but the array underneath it may contain 10, but only the first 5 elements matter. How do you know how many elements of the underlying array matter? Let's say you got an array of length 100. The first so many are actually the elements of the list you're representing. The rest is just room to grow. How do you know which is which? Which elements are real and which elements are just space for future expansion? Yeah?
This last element in the array, the count.
It's count. Right, so if you have a list that's of size 50 that's represented with an array of length 100, the value of count would be 50. Count's not the size of the array, count is the size of the list that's being represented. And that would tell you that the remaining 50 elements in that array are there for future growth. So, let's play this game again. There is I got one more. Okay, there's the internal representation of a version 2 my list. So we've got a data array that contains 1, 5, 9, and 2, and a count which is 3. What my list is that? What list is that? What does the list it represents contain? Yeah?
1, 5, 9.
Yeah, 1, 5, and 9. That 2 is just, it doesn't matter what it is, it's just room for future growth. When we actually use that element, we'll store something else in it. Yeah?
So if we did count equals 4, the list that we're returning would be 1, 5, 9, 2.
Right, if count were 4, as he said, then it would represent the list 1, 5, 9, 2. Yeah?
And I'm not sure if you answered this yet, but what if the count that you set is higher than the number of values that's in the array?
Okay, so what if count were 5? Let's hold that thought. I think I got an example coming up. Okay? What about this one here? The data array contains 8 and 2. The count is 0. What list is that? It's the empty list. Count determines the size of the list. Okay? Now, where does this rule come from? Is it part of Java's definition that if you use a variable called data and a variable called count, that this is the way they will relate? Where does all this coming from? Yeah?
How we made our instance variable?
Say a little louder.
How we made our instance variable?
Yeah. It comes out of this. We designed the representation right here and documented it. It comes from here. You know, it says right here, the elements in the list are actually the ones stored in the first count elements of data, which implies that the rest don't matter. It's just there for future growth. So this is just our decisions come to life. Okay? What about that? So our data array contains a 9 and a 2, and count is 3. What list is that? Back there.
Would it just be 9, 2, and null?
9, 2, and null? Well, I mean, the problem is you can't have an int null. Reasonable guess, but no. Yeah?
9, 2, 0?
9, 2, 0? Well, let's go look back at our rule here. It says the elements, okay, the length of data must be greater than equal to count. Okay, that was a restriction we put on ourselves. We sort of promised ourselves with that comment that we were never going to have a data longer than count. And yet,
Count lower than data.
okay, and they're going to have a count more than data. And yet, there it is. Yeah? Right, you can't do it. Yeah?
What is throw an index exception?
Well, it depends on, she asked, will it throw an index exception? It depends on what's happening in the code. The bottom line is, this is not a legal representation. If it ever exists, if your program is running and at some point, after some method has been called, data is an array of length 2 and count is 3, and a legal representation has occurred. What does that mean? Yeah?
You should throw an exception.
No, not that you should throw an exception. What does it imply? If your code ran along and got to this point where data was 9, 2 and count was 3, yeah?
You did a mistake in the code.
You made a mistake. It's your bug. It was your job to make sure count was never bigger than data. So maybe you forgot to double the length of the array or something. But it's your bug. No one did this to you. No one can modify your objects unless they come in through your methods, right? So only your code, even if you got 1 million users, they can't go and muck around with data and count. They have to go through your methods that you wrote, and their job is to make sure that, that you follow the design. So if you get the situation, you screwed up, and you need to fix it. Now, how can we be sure that these 1 million users, that one of them didn't modify data directly or count directly? How do we know they didn't come in and just set count to 3 just for the heck of it and see what would happen? Yeah?
Because count is private.
Count is private. That's another reason we make instance variables private. We make them private so that we can change our mind in the future and use a new representation. We also make them private because a lot of times there's a complicated relationship between the variables. There's a relationship here, right? Count has to be less than or equal to the length of data. We know that, and we can keep that in mind as we're writing our methods. We don't want to trust the rest of the world to make sure that stays the case, so we make them private. Only we have access to them. And that lets you know that if they get into a state that's not legal, from our point of view, it's our fault, and we need to fix the problem. Okay? Let's go the other way. Suppose you had a list like that, 438. What would be its internal representation? What would be the values of data and count you expect to see if what you've got is a list object that you know contains 4, 3, and 8? Yeah?
Count that's at least less than 3, and then depending on what that is, the size of it.
Okay, well, first of all, we can definitely say what count is. What does count have to be? 3. Because count is the number of elements in the list. We can see there are 3.
Well,
What?
but before there was an extra one that you could chop it down. So the count could have been 2 and the gray list could have had 1.
Well, before,
Oh, yes.
count, you see in all of these, count is 3, there's 3 elements in the list. Count is 0, there's no elements in the list. So if we want to have something that represents the list 438, it had better have a count of 3. But what will the data array look like? What will the data array have to contain to represent the list 438? Yeah?
Would have to be an array of 438.
Okay, so it has to be an array that first element is 4, next element is 3, next element is 8. And that may be all, or they may be longer, and there may be, we don't even care what comes after that. So here's, that's one possibility. Data, data is 438 and count is 3. That's sort of the simplest possibility. Okay, here's another possibility. Count is still 3, but data is 438 and then 925. And that's just room for growth. It's another possibility. So if you know the concrete representation of an object, you can uniquely determine, if you understand your representation, which abstract object it represents. But there's not necessarily a one-to-one way to go the other way. Okay, what about that? How would you represent an empty array list, or an empty my list here in this new strategy? Yeah?
Data can be whatever as long as it counts 0.
Data could be any array whatsoever. Count has to be 0. So there's one possibility. Now, how would you get an array like that that contained a 5, a 6, and a 1? Yeah? Okay, I think what he said was, you know, you imagine you start with an empty list, you add a bunch of stuff, and you get a long array, and then you start deleting stuff from your list. We didn't actually implement a remove method, but suppose we did. What's the simplest way to implement a remove method? If someone says remove the last element of the array, of the list. Just subtract 1 from count. You don't have to change data at all. And so that remove is how you could end up with old elements that have been deleted. So one way to think about this is the array used to contain 6 elements, but we deleted the last 3. So 4, 3, 8 still matter. The 9, 2, 5 are just leftover artifacts. They don't mean anything. They'll be replaced if we ever need that space again. Okay? All right, so that's the stuff that we talked about before fall break. We were working on these 2 classes. And what we found was, by making this simple change in representation, such that only every now and then did we have to double the length of the array. Then when it filled up, we double it again. So the doublings got less and less common, because they only happen when they fill up. We had one method that, the original representation, it took like 15 seconds to do 400,000 insertions, whatever it was. How long did it take the second version to do it? I mean, it was point something. It was basically, I just hit enter and it was done. So it can make a dramatic difference to choosing the right representation. Okay? So any last questions before we turn to something different? Another example of this. Yeah?
Should we always include Java docs with our instance variables?
Okay, the question is, should you always include Java docs with your instance variables? Such as this one has. And the answer is yes. And again, this isn't documentation that anyone that uses your class would need to know. They can't even see those variables. It's there for your benefit. Because suppose you just wrote, okay, I got private int count, I got private int data, and you gave no documentation, private int array data, and you gave no documentation, you didn't write it down. So you go to implement your add method and you think, you implement it making one set of assumptions about how count and data relate, and then you go, you implement size and make a different assumption, and suddenly your methods are incompatible. If you carefully document your design decision, then you can draw on that when you implement your methods. Yeah.
So the only thing, I usually just do like line comments, but
Yeah.
JavaDoc just makes it easier to like hover over that later and.
Right. In fact, so what he said was he generally documents them with just / inline comments. And that's what I used to do. Until someone pointed out to me that you can't take advantage of JavaDoc. You know, if you'd like to look up the documentation on your instance variables, you can't if they're not JavaDoc. So, and I used to say, well, you know, I used to not like, let me go to count here. A lot of times I have very simple comments on these things, like the number of elements in this list. And I don't like the fact that it takes 3 lines to do that. Then I discovered you could do this. So it's still JavaDoc, but it's just on 1 line. Right? And so now if I come down here to count, it pops up. So I've done it both ways. Any other questions? Yeah?
So like, I understand all the logic of this stuff right here, but like, what would be like an application of this? Like, it just seems just like all very abstract.
Okay, so he said he understands the logic, but what would be an application of this? Why would you ever, in other words, why would you ever want to create a class that provided a new type of object? Okay, so why? Yeah?
I mean, I guess an example is like in the design book, they have the restaurants bar,
Okay? So she's referring to the Zybook example. But the bottom line is, suppose you're implementing a program dealing with restaurants. And so you say, you know, I could use a menu object. I wonder if Java provides a menu object in its library. And you go, oh, there is a menu object. And then you discover, oh, it's for graphical user interfaces, it's not for restaurant menus. So when you write a program, you need access to the objects that you need and to the methods that you need. And we learn how to supply new methods, new static methods. This is just another thing. It's a building block for a program. It's a piece. Aren't you glad that Java provides array lists? Right? There's your use case for the usefulness of classes. You know, there wouldn't be anything in the Java library if there was no way to create new classes. They were all programmed up this way. And when you go to implement a program, sometimes the classes you need are in the Java library and you're in luck. Other times you just have to build those pieces. You've got to build something specific to your case. Any other questions? Yeah?
So I'm still trying to graph instance variables. So like with the count instance variable, how do we ensure that it is the number of elements in the list? Like,
Okay, so she says, we know that count is supposed to be the number of elements in the list. How do we ensure that? Well, let's see how I did it. So in the constructor, I set count to 0 because, why? What's the Java doc say up there? Creates an empty list, and count's supposed to be the number of elements in the list, so it better be 0. Okay? The get method, I don't change count because the list isn't changing size. Okay? Set, I don't change count because the list isn't changing size. Add, right there. I added 1 element, so the count is 1 bigger, so I add 1 to count. And I don't change it in size. So essentially, as you implement each method, you just have to keep the instance variables in mind. How do they need to change? Like this is the most complicated method. It says if our array has filled up, we need to make one that's twice as big. Then we can store the new element in increment count. That keeps our variables organized according to our plan. Any other questions? Okay, so you know when you first implemented static methods, it felt kind of weird. You know, how do you know how to write the code? And you've got a lot of practice with that. Same way with classes, it just takes practice. Okay, let's take a break and then we will look at another example. All right, let's get started again. So here's our challenge for the rest of today. Let's imagine that the Java library didn't have maps. And so we're going to create a class called MyMap. And it will let us create an empty map, like there. And our map is going to map strings to strings. We can put a key value pair in there, so that maps Utah to 4. We can put another key value pair in, another one. We can calculate size. We can look up the value of a key, the get method. And we can remove a key value pair by giving the key to remove. So some of the same methods that you see in tree map or hash map we want to provide. And of course, since we're assuming that Java doesn't provide maps, we can't use hash map or tree map to implement this. There's no point in doing this except as an exercise. Okay? So what's the first thing we have to do? Besides, well, I need to show you you have to design the class. You have to figure what method you want. So we have a constructor that creates an empty map. We have a put method that will associate key with value. We have the remove method that takes the key value pair out. A get method, which gives you the value associated with a key, or null if it doesn't have one. And we can return the number of elements in the map. So those are the methods we need to support. So we've got to figure out we need to design a representation. We need to figure out instance variables that'll make this work. And that is, if you make a good decision when you design your representation, then the rest of the implementation can go very simply. If you make a bad decision, you may find yourself having to work really hard in every method. And if you find yourself doing that, what you want to do is maybe admit you made a bad design and go change your instance variables. Okay? So let's talk about it. How could we represent maps? Go ahead.
Yeah, how you call someone else?
Nope.
Okay. This lecture isn't available on Canvas to follow along.
Huh?
Yeah. And I have a hard time understanding what's going on in this line.
It's right there. October 21st, 27th.
It's not available to take from the, I don't have it either.
What's the problem?
I think she probably hasn't updated her CPU.
Yeah, try refreshing
I
your.
can't see.
Yeah, it should be visible.
I don't remember how to update it.
Just go right here and refresh your browser.
No, I'm not talking about that. I'm talking about the Java project.
Oh, you're right. Sorry about that. I neglected to do that, so I apologize. But I can't fix it right now. So, representation strategy. Yeah.
2 arrays of strings where each index aligns, like index 0
Okay.
is one key, index 0 is...
All right, so what he's suggesting is, imagine you have 2 arrays. Every MyMap object has 2 arrays inside of it. Maybe we call one keys.
Arrays could actually be lists. Lists exist.
Yep. And the other values, right? And so let's say there were 4 keys. You'd have an array containing those 4 keys, A, B, C, D. And then you'd have the values array would also contain 4 elements, and it would contain the corresponding values. So under that strategy, how would you look up the value associated with a key? We're using these parallel arrays. Yeah.
Look up the value at the same index of the
As the key. Right, so what you would do is you would take the key, you would search through the keys array to find where the key is. Say it's at index 7. Then you would just drop down to the values array, and the value would be stored at index 7. Okay, that's a common technique. Okay? Now he's already changed his mind, but what he said originally was 2 arrays, a key array and a value array. Who can improve on that? What's the problem with using arrays? Yeah,
You can't change the size.
can't change the size, so we're sort of back to,
Sorry, I was still assuming that.
yes, you understand, I'm just making a teachable moment out of it. All right, so let's just use array lists, right, instead of arrays. Now, suppose array list didn't exist. Could we do better than using a pair of arrays? One containing keys, one containing values? Yeah? Well, hash map or tree map, yeah, we're assuming they don't exist. Yeah?
We could use MyList.
Use MyList, right. So if you're in a world where array lists don't exist, we just implemented essentially array lists. Now, it's not quite what we need because it's a MyList that holds ints, and we would need a MyList that holds strings. But that's a story for a different day. But we'll just use array lists. Okay, so let's look at what that would look like. Let's see where I got to here. My map. Okay, so here's my documented representation. So I'm going to have an array list called keys, an array list of strings called keys, and an array list of strings called values. And look at the comments. The keys list contains the keys of the map in no particular order, and there are no duplicates. And for the array list, it says it's the values of the map. This list has the same length as the keys list, and the values are stored in corresponding locations. If the key is at location I of the keys array, the value will be at location I of the values array. So that's our strategy. So let's do this game here. You've really got to understand your representation strategy before you start trying to code. Okay? Representation to abstraction. Suppose that you cut an object open, and the keys array contained A, B, C, and the values array contained X, Y, Z. What map is that? What is mapped to what? Okay? What does C map to? Z. So that might be the way you'd write that. Right? That's meant to suggest that it's a map where A maps to X, B maps to Y, C maps to Z. Okay? Suppose you cracked open a MyMap object and you saw that. What would its representation be? So there are no key value pairs at all. It's an empty map. And what about this one? You crack open your object and those are the keys and those are the values. Yeah? Well, A to W, B to X, C to Y, but what about that Z? Okay? Back in my strategy, my representation strategy said the values array had to be the same length as the keys array. So if this situation arises, you made a mistake. Yeah? Way louder. Even louder. Because we're essentially, he's asking why are we using array lists instead of hash maps? Because we're implementing maps. We're pretending hash maps don't exist. No. He asks, is there a benefit to pretending that hash maps don't exist? No. I'm just trying to, what I'm trying to do, instead of making up some data, some class where you don't know what the methods mean at all, I'm trying to use something that's familiar to you so we can focus on the coding instead of on what's that method supposed to do. It's just a strategy. Okay, so there's that. And what about, no, that's that. All right. So when you design, play around with it until you understand it so you can code properly. Now, let's see, what was it? Private. So we had keys. And we had values. And after class, I will I'll copy those comments in. I don't want to take time right now to copy those comments in. We can refer to them on the slide if we want to. Okay, so now once you've got your strategy design, you can implement each method without worrying about the other methods. You just got to, use your representation strategy correctly. So this says creates an empty mind map. Well, we just saw how you would represent an empty mind map. How was it? What did the slide show? What was the internal representation of an empty map? Yeah?
Is that where you set keys equal to just an empty list?
Right. So we just have them both be we have an empty list for each. So there are no keys or no values. So that is an empty map. And you might ask, why is that an empty map? What's the answer? How can I look at that and say, yeah, that's how you represent an empty map? Yeah? Say again?
Is there no parameters?
Well, we know we're supposed to create an empty map because it says right there. But why is this particular combination of keys and value? Why is that the way to represent an empty map? Yeah?
These are both new objects.
Well, they're both new objects, but yes. Well, they are initialized. Those are empty. Both variables are initialized, and they're both empty array lists. But what makes that the correct combination of values? Yeah.
There's no values being passed through them?
Well, no values are being passed in as a parameter, but that's not what makes them right. I can see a hand at the back. Yeah.
That's the representation you decided.
Right. That's what we decided. Okay. If I didn't
repeat.
Okay. Well, he said that's just what our representation scheme says. Now, if two people came to my office and they both showed me just this, and they said, is my constructor correct? What would I have to say to them? It depends on your representation strategy. Right? I could have one student come in and that's their constructor, and I look at their representation strategy, and I say, yeah, that's right. And the next student has exactly the same constructor. And I look at their representation strategy and say, no, that's not right. It all comes down to your design. You have to decide how you're going to represent maps. And you got to stick to that decision. Yes? Okay, you want me to show the representation strategy?
Yeah.
Okay. Right there. Those are the comments I'll copy in later. So it says right there that the keys, this array keys contains, or this list keys, contains the keys that the map does. So whatever the keys the map has, they go in that list. The order doesn't matter. The order in which the keys appear doesn't matter. And we're going to make sure there are never any duplicates in that list. And then it says that the values array contains the values. We're going to make sure it always has the same length as the keys list. And we're going to make sure that keys and values are stored at corresponding locations. So if the key's at location 5 of the keys array, the value will be at location 5 of the values array. That's our plan. So you've got to have that in mind as you code. So let's keep it in mind. Okay, so this looks right. The keys is supposed to contain the keys, and values is supposed to contain the values. And there aren't any keys or values, so that's good. And they're the same length, so I think we're good. But notice how different this is from implementing a static method. If I have two people come to my office and show me their static methods that are implementing the same spec, if they're exactly the same, they're both going to be right. But with these non-static methods, you can't say whether something is right without knowing how you're choosing to represent your objects. And that's the first thing a TA would ask you. If a TA comes over, you call a TA over and say, I don't, what's the bug? They're going to have to know, well, what's the strategy? What's your representation strategy? And if they look and your strategy looks like mine and doesn't have any comments, I've got an excuse. I just didn't want to spend 5 minutes typing it in. You don't have an excuse. You need to be explicit so the TA can read it and go, oh, that's your strategy. And so you can read it and say, ah, that's my strategy. Otherwise, you implement a method today using your strategy, and then tomorrow you implement another one, but you forgot your strategy, so you do it a different way. They won't get along. They won't cooperate right. Okay, how do we do it? We're given a key and a value to add to our map. Yes?
I have a question. When writing larger programs, do you have like a document that your team or just programs can read?
Yeah, okay, so he's asking if you're writing a larger program with multiple people, could there be external documents that the team uses? Certainly. Yeah, but for our purposes, we try to keep all our design documentation in the source file. Okay, so what's it going to take to add an element to a map? What do we have to do to our keys array and our keys list and our values list? Yeah?
Just add these parameters to each of the arrays.
Okay, so it sounds like we want to add a key to the end of the list. So we'll add the key to the end of the list. And we'll add the value. So let's see if we did this right. So it makes sense that we're adding a key because keys is supposed to contain all the keys. We added a value. Are two lists the same length? Well, if we code it right, they'll be the same length when the method is called. So we'll assume that they were in good shape when we were called. So yeah, we just increased the length of both by 1. But we've screwed something up. What did we do wrong? Yeah? What if there's a duplicate key? What's supposed to happen when there's a duplicate key? Yes? Say a little louder. Okay. So paraphrasing, if the key already exists, we need to replace its value. So we got to break this into cases. So how can we tell if the key already exists? What do you think? Okay. It's not contains key, it's a list op. There's a list operation called contains. So we ask, does the keys array contain the key? And it either does or it doesn't. Now, some of you might have realized, I need to know whether the array contains the key, and then written a loop to figure it out. Nothing intrinsically wrong with it, but why write a loop when you don't have to? Someone already wrote the loop for you and called it the contains method. So it pays to know what you've got. So if the array does not, if we do not already have this key in the map, we're doing the right thing here. What should we do here? Yeah? Okay, so is there a, we've sort of got, what we got to do is figure out where key is in the array, get an index. That's the first step. And then we can change the values array at that index as well. So how do we find that index? I do keys dot and I say, is there a way to look up? And there's index of. That sounds good. So we will find out at what index of the keys array this particular key is stored. And then what do we do? Yeah? Right, we do a set operation. We say change at the given index, store a new val in there. So those are our two cases. We've got key exists, key doesn't exist. So it does the right thing in both cases. And that's the game you play. But you can't judge whether this is correct unless you have a representation strategy. And you've got to write it down or you'll forget it. Yeah?
So what is the if statement doing?
Okay? The if statement is asking, does the list already contain this key? Because if the key is already in that list, that means that the map that we're representing already has a key with the value, a key by that name with the value. If it doesn't have that key, we just do what we do our gut instinct, which was to add the key to the end of the keys, the value to the end of the values. If the key does exist, we find out where it is in the keys list, and we go store it at the corresponding location of the values list. We store the value at the corresponding location. So if the key was at location 4 of the keys array, we change what's stored at location 4 of the values array. So the arrays didn't get any bigger, we just updated up. We have a new value stored for the key. And that's the put operation. Let's choose a simpler one here. Returns the number of elements in the map. So the number of key value pairs in the map. How do we calculate that? How many key value pairs are there? Yeah?
Well, if we did it right, the number of keys and number of values should be the same, so just return the length of one of those lists.
Yeah, return the length of one of those lists. I'll just say return keys dot size. Or I could have said return values dot size, because they're supposed to be the same length. As long as we're doing our job, they will be the same length. So what we're doing is, remember I said before fall break, you know, when you implement a class, you've got this old adage, if it looks like a duck and it quacks like a duck, it's a duck. You're trying to make this pair of lists behave like a map. Okay? What about the get operation? Someone says, here's a key, give me the corresponding value. Okay? Okay? You need to make sure it exists. So I'm going to do it a different way. Let's just do this operation here. Let's just look it up. Okay? Now, what if key exists? It'll tell us where it is. If key doesn't exist, what will happen? Let's see what it does. It says it returns -1 if there's no such, if the element doesn't exist. Okay, so we're going to look it up, and what do we do? Meaning the key does not exist. Yeah? Return null, as it says right here. That's what you do if the key doesn't exist. Okay, and suppose the key does exist. Someone else tell me. What do we return if the key does exist and is stored at the given index? In the back there? Well, but what is the value of the key? What do I type? Okay, right. Values dot get of index. Boom. And we're confident that's where we'll find the value, because that's what our representation says, and we're being careful to live by the rules of our representation. Now, suppose you're testing get and it fails. Does that mean there's a bug in get? Yeah? Maybe. Where else could the bug be? Yeah? Well, yeah, it could be we made a mistake when we did the put operation. Maybe the problem is there. We didn't add correctly, therefore violating our design decisions, and therefore none of the other methods work right. Okay? So be careful when you test that you don't assume too much. Just because you were testing get and it failed, well, before you could test get, you had to call the constructor and you had to do some adds, and then you could test get. The error could be either way, either place. Now, and that's an important point, so I'm going to look at, I have tests here. So let's look at what it takes to test a map, because you're going to need to test your classes. So let's see, I want this first test. What's it doing? It's creating an empty map. It's making sure the size is 0. And it's making sure that if you look up a non-existent key, you get back null. So typically with classes like this, you can't test a single method or a single constructor at a time. You have to test them in combination. Okay, let's look at this test. So we create an empty map. We add 3 key value pairs. We get that the size, we assert that the size is 2. And why is it size 2 instead of 3? Yeah? Right, we put A twice. So there's still just 2 keys in there. We assert that when you look up A, right here, you get 3. You look up B, you get 2. And you look up C, you get null. And let's say this assertion failed here. Probably doesn't mean size is wrong. That's so simple. It probably means that you did something wrong in put. And here's some other methods. That's what it takes to test a class. You have to create some objects. You have to build them up. You have to make assertions about methods that look into them. So a little bit more involved than the other. Okay, so we've got size, we've got get, we've got put. All we need is remove. So conceptually, what does remove need to do? You've got an array of keys, an array of values. You want to remove a key. Okay?
Take an element off list.
Well, I think what she said was we need to take an element out of each list. The question is which element? The easiest would be to take the last element off both lists, but we're not asked to remove anything. We're asked to remove a particular key value pair. So we need the index of the key. Well, we know how to do that. In fact, there are going to be 2 cases again, so let's just copy this. Oops. So we're going to get the index of the key. Now, what do we do if the key doesn't even exist in the map? Yeah? Yeah, it says does nothing in that case in the comments, so we just do nothing. And in fact, I guess what we're going to have is we just do it this way. If index is not equal to 0, not equal to -1, then we do something. Well, what is it we do? We need to remove the key at index, and remove the value at that same index. How do we do that? Sounds hard. How are we going to modify keys to take out something at a specific index? Well, we cross our finger, we come down, and there's a remove. Right there. Why is it not in alphabetical order? It's weird. So there's a method called remove that takes an index and removes the thing at that index. That's fortunate. So we'll just remove the thing at that index from keys. Now, what if we just stopped there? What have we done? What have we done? Yeah. Right, now if we stop there, our arrays aren't the same length. We've thrown off the correspondence between keys and values. And remove would return that somewhere down the line something would blow up because we've screwed things up. We need to also remove from the values array. And now they're all gone. Okay, so what did we do? We did our strategy, which I still need to document, using the comments on the slide. We did our constructor, we did our put method, we did our remove method, we did our get method, we did our size method. And the question is, we need to find out, do they all work and do they all work together? Because that's the bottom line. They'll work together they're much more likely to work together, right, if we kept our representation strategy in mind the whole time. But I have some tests here. Let's look at, so that one there, let's see what it does. It does a bunch of puts, makes some assertions about get, it removes, makes some more assertions. Here's one that, see, I love these things. It does 10,000 times. It like adds a bunch of stuff, adds some more, removes every third element, makes some more removes, asserts stuff about the size. So that's what I call a stress test. And I can make it as nasty as I want by increasing the size of this. Okay? What I find is students are a little too delicate when they test their code. They want to write test cases that look like this. But a real serious test case, you're probably going to have loops in there to pound. If you're going to pound on your data structure, it takes loops to repeat things over and over again. And I understand, if you're kind of shaky about loops, you don't want to have to write them in your test case. Let's see if this works, or if I made a mistake. Okay. I had all of you to help me here. Let's go and screw something up here. Okay? And let's see what happens. Go back to here. So we passed test 1 and test 2 because they didn't do removes. Test 3 failed, and if we go, it says it failed on, it said expected to get 14 but got 21 back. So there's the assertion that failed. We went to get the value of b, and instead of getting back 14, we got something else. So again, the problem is not with get. You saw what I did. The problem is with remove. So it can be really tricky. So what do you suppose is your strategy if you start failing tests? How do you track down where the problem is? Yeah?
Run in debug mode and watch the variables.
Yes. So what he said was run in debug mode and watch the variables. So let's do that. Let's take a breakpoint right before this method. And let's run this test in debug mode. We get the same error. But now we can go, like there it says, okay, here's our object. Now, you can't really see this. I don't have it set up to blow up. But anyway, we were operating on this on M. And I expanded M, and there's keys and there's values. If I click on keys, you see keys contains BC. I click on values, so I use that term, crack open the object. That's what I've done here. I just opened up M in the debugger. I can look at keys contains BC, values contains that. And right away you say, oh, that's not how things are supposed to be. So then you need to trace it back and find out where did the two arrays get out of sync. They're supposed to be the same length. So use the debugger, and in the debugger, even though they're private, you can look at those private distance variables for each object, see what's going on. Okay? All right, we'll continue along with stuff like this next week.